Welcome to another installment of Terrace Tips. Today I'm going to show you how to take roots of complex numbers the easy the way I teach all my students to do it in my college math methods classes. Suppose you're asked to find the cube roots of 8i. That's the same as solving the equation x cubed equals 8i. The first thing I do is I rewrite this as x equals 8i to the 1/3. Now this to the 1/3 doesn't mean find just one root, it means find all the roots. And my strategy for finding all the roots is now I find all the different ways that 8i could be written in polar form. Remember that we can write any complex number in polar form. We think about it on the complex plane and we plot it. In this case, 8i is up on the imaginary axis since it's purely imaginary. And we see how far it is from the origin, in this case 8. And we see what angle it lives at from the x-axis, in this case pi/2. And so we can write 8i as 8, its distance from the origin, times e to the I pi/2. But that's not the only polar form of this complex number. Remember, the angle is ambiguous because you could also do pi/2 plus 2 pi. Remember, 2 pi is going all the way around the circle. In fact, you could also do pi/2 plus 4 pi, or 8 pi, or 28 pi, or minus 36 pi. You could do I pi/2 plus any 2 pi I n, where n is an integer. So this is the general polar form of the complex number 8i. And now we can calculate. 8i to the 1/3 is therefore 8 e to the I pi/2 plus 2 pi I n, all to the 1/3. And the 1/3 just comes down. 8 to the 1/3. And e to the something to the 1/3 is e to the 1/3 of the something. So it's e to the I pi/6 plus 2/3 pi I n. Or 2e to the I pi/6 plus 2/3 pi I n. The secret here is once this 1/3 acts on the real number 8 in the polar form, then it just means the real root 2. Okay? So now we have the answer, but I'm guessing your teacher wants something more specific. He or she probably doesn't want an arbitrary integer n in the answer. But we're almost there. We just plug in for some integers. So start with n equals 0. We got 2e to the I pi/6 plus 0. So that's simple. N equals 1. 2e to the I pi/6 plus, now n is 1, so 2/3 pi I, which is equal to 2e to the 2/3 pi I is 4/6 pi I plus 1/6 pi I is 5 pi I/6. And keep going. N equals 2 is 2e to the I pi/6 plus now 4/3 pi I, which is going to be, this is 8/6 plus 1/6 is 9/6, 2e to the 9 pi I/6. Keep going. N equals 3. Actually, we don't keep going. We stop. Why do we stop here? Well, these are cube roots. We know in general there's only going to be 3, and we already found 3 roots. So we don't need to do any more. We could continue and use this formula, and we would get 2e to the 13 pi I/6, which might look like a different number, but it's not. It's actually the same number as n equals 0 because of that 2 pi difference in the angle. But you don't need to know that. You can just realize you were doing cube roots and you found 3, and so you can stop. And that's it. We have the answer. The answer for the cube roots of 8i is 2e to the I pi/6, 2e to the 5 I pi/6, and 2e to the 9 I pi/6. You could expand them out in Cartesian form using Euler's formula if you want, whatever the question asks or whatever you're trying to do. But in any case, this is the answer for the 3 cube roots of 8i. If it were the 10th roots of some other number, you do the same thing. You write the other number in polar form, with a 2 pi n in there. Then you raise it to the 1/10 power, you go through it, and then you find not 10 different roots, because that's how many there will be, and then you write them out. And so that's how you do complex roots the easy way. I hope you enjoyed that. If you want to have some more practice, head over to Tutor Terrace. We have free practice problems with solutions where you can test your understanding. And if you need a little boost, we're available for booking tutoring sessions on the website.